Okay, so the first thing we're going to be doing is the piecewise functions page you picked up, and it will go on page 142. Okay, if you're a color coding person, today would be the day to have your colors to color code. So piecewise functions are functions represented by a combination of equations. The rule for a piecewise function is different for different parts or pieces of the domain. For example, movie ticket prices are often different for different ages. Remember when people went to the movies? That was nice. That was a good time. So the function would assign different ticket prices for each domain or age group. A special kind of piecewise function that is constant for each interval of its domain, such as a ticket price function, is called a step function. Are you ready for it? Because it resembles a set of stairs. I know that's the craziest thing you've heard all day long. All right, so before we write this equation, let's look at it and just figure out what in the world it means. Okay, so over here on the left, we have the price. Across the bottom, we have ages, and this is the admission price. So this first line of our graph right here means, actually, what ages is this talking about? Of a child, yes. Starting at age what and ending at age what? Okay, starting at age 0, ending at age 7. So anyone from birth to 7 years old costs $5 for their ticket, which I think is silly. I'm not going to pay $5 for my newborn to come watch a movie, but that's just me. Okay, but once you turn 7, what happens? Someone other than Chris. The price increases to how much? $20. I'm going to have to start calling on you people, and you're not going to like it. Okay, so once you turn 7, up until you're 12, it costs you $20, not 12, $20 to go see a movie at this place. It's got to be the IMAX or something, right? Okay, and then once you turn 12, you jump way up there, and now your ticket is going to cost you $45. Okay, so let's just think about it. You guys go on a date to this place, cost you $90 to see a movie. Just 2 people. It's insanity. No one should do that. All right, so anyway, that's what this graph means. There would be an arrow right here that would go on forever because there are people who are older than 18. Okay, so I'm going to write an equation for this, and it's going to look like a piecewise function, which means I'm going to have an equation for each piece of the graph. And how many pieces are there? 3 pieces. Okay, so my first piece is $5. So you're going to pay $5 if your age is between 0 and 7. Are we including 7 here? No, because it's an open circle. Since it's an open circle, 7 is not included. So if you're between 0 and 7 years old, so we're going to go with the cost is your equation, and then your age over here is your domain. So what's my next cost? 20. And you have to pay $20 starting when you're 7 up until you're 12, right? So 7 and 12. Sorry, that one should not be an or equal to. So 7 is included in this one because it's a closed circle. 12 is not because it's an open circle. Then for our last one, our cost is a ridiculous $45 if your age is 12 or more. So x greater than or equal to 12. And that is what a piecewise function looks like. Okay, it's called a step function because it steps up. They look like steps because they're flat. So it's weird, but not overly crazy, right? Please say yes. Okay, we have 2 people that are talking today. All right, we're going to skip A for just a second. We're going to come over here to part B. So it says find f of negative 3, f of 1/2, and f of 1.5. I'm going to start with the 1.5. So what I need to do is I need to figure out where 1.5 falls in all of these domains or restrictions over here on the right. And then once I know that, I'll have my value over here. So what 2 whole numbers does 1.5 fall between? 1 and 2, okay? The only one of these that has 1 and 2 is this one. So when x is 1.5, your y value is 1. So f of 1.5 equals 1, because that falls in this piece of my piecewise function. The next one we have is f of 1/2. So what 2 whole numbers does 1/2 fall between? 0 and 1. So that's going to be this one, because we have 0 and positive 1. So if it's between 0 and 1, your y value is 0. So f of 1/2 is 0. Okay, and then the last one we have is f of negative 3. Which piece does negative 3 fall in? What? It doesn't. It doesn't fit in any of these domains. So we don't know what it equals. So it's undefined. So if they don't tell you what it equals for that specific domain, it's just undefined. Okay, now let's go back up and do part A. First one they want to see is f of negative 3. So is negative 3 less than negative 1 or greater than or equal to negative 1? It's going to be less than. So I'm going to take negative 3 and plug it in for x into this first piece. So negative 3 minus 4. Once you figure out which piece you're plugging it into, it's like the other equation doesn't exist. You only have that first one. What is negative 3 minus 4? So f of negative 3 is negative 7. Now we have f of 4. Is 4 less than negative 1 or greater than or equal to negative 1? Thank you. It's greater than or equal to negative 1. So I'm going to plug it into this second equation. It's like the first one doesn't exist anymore, and I just have this one. When I plug in 4, I have 3 times 4 minus 1. What's 3 times 4? 12, and 12 minus 1 is 11. Okay, the last one, f of negative 1. Which piece am I going to plug negative 1 into? Top piece or bottom piece? Ethan, the bottom one. because -1 is greater than or equal to -1. So I have 3 times -1 minus 1, which is what, Shelby? Mm-hmm. All right, you guys do part C. All right, turn and check your neighbors. You get 1/2 and 15. Sweet. Are you feeling okay so far? All right. Now we're going to take a graph and write a function similar to what we did on the front, just without all the words. Okay, so how many pieces is this graph going to have? 3 pieces, so 3 pieces of our equation. Okay, and I'm going to start with the flat pieces because I think those are easier. Okay, if it's just a plain horizontal line, what's the slope of that line? 0. Okay, if your slope is 0 in a y equals mx plus b, won't this term go completely away? It'll just be y equals the y-intercept, or y equals a number? Yes. Okay, so what is my y value for all of the points on this line? 4. So the equation of this line is y equals 4. So for my first piece, it's going to be y equals 4 if we're talking about x values here. What's my first x value that I have? -2, and it's going to be everything to the left of that, right? All of these numbers, -4, -6, those are less than -2, so it's to the left. Are we going to include -2? Yes, because it's a closed circle. So y equals 4 if x is less than or equal to -2. Okay, I'm going to do that same thought process on this piece down here on the far right. For this piece right here, it's a horizontal line, so my slope is 0. So it's just going to be y equals a number. What's the y value for all of these points on this line? -3. So y equals -3 if, what's my starting x value? +2. And then all of the numbers to the right are greater than. Again, it's a closed circle, so it's going to be if x is greater than or equal to +2. Okay, now we have this diagonal line here. So since it's not horizontal, that means it's got a slope and a y-intercept. So for this middle line right here, what's going to be the slope of that line? Close. -1. I'm going down 1, right 1. So my slope is -1/1, or -1. What's the y-intercept? What's a y-intercept just in general? It's the point where it crosses the y-axis. Well, at what point do we cross the y-axis? 0. So the equation of this line that I've colored purple is y equals -1x plus 0. Do I have to have that -1? I don't have to have the 1. I have to have the negative. Do I have to have the 0? No. So I'm going to make this -x if, okay, this one's a little weird because it has a starting and an ending point. So if it starts at -2 and ends at +2, I have open circles, so neither one is included. So x is between -2 and +2. Simple? I tried to make it as simple as possible. I cut out all the complicated parabola ones. Shelly, your eyes just now. Oh. All right, part B. How many pieces do I have this time? 2. Are either one of them horizontal? No, sadly. All right, so one piece at a time. Let's look at this piece right here. It's not a horizontal line, so I need to find the slope and the y-intercept. So I have this point as a starting point, and the line also looks like it goes through this one right here. Yes. Either 1 over -2 or -1/2. It doesn't matter. Either way, it's -1/2 because you go down 1, right 2. So your slope is -1/2. Can we see where this line crosses the y-axis right now? No, we cannot. But if I were to continue this, down 1 over 2, it would go and cross right here at 2.5, right? So 2.5. So the equation of this blue line is y equals -1/2 x plus 2.5. So that's my equation. If, what's going to be my domain on this one? Is it going to be greater than or less than? Less than or equal to, because it's a closed circle. My x value, which is -1. Okay, go ahead and try and find the equation of the other piece. See if you can do that one without me. What? All right, check yours with mine. How'd that go for you? Ooh. Kind of, sort of. All right. Now we're going to go the opposite direction. We're going to get the equation and make the graph. It's going to go on page 143. I'll give you a second to get all that sorted out. Okay, so for this one, we need to graph each piece one at a time. And so I'm just going to show you the way I do it. There are other ways, but this one I feel like is the most straightforward. So looking at the domain, I'm going to take this x value of the domain and plug it in to give myself a starting place. So take that and plug it in to get a starting place. If I plug in 0, negative 0 is just 0. 0 plus 2 is 2. Is that going to be a closed circle or an open circle? An open circle, because it's less than. So at the point 0, 2, I'm going to put an open circle. Okay. This is in y equals mx plus b form. What's my slope? Negative 1, right? Negative 1 over 1. So way back in the day when you were in Algebra 1, you would have started at your starting point, gone down one, right one, and drawn a line once you had a few points plotted, right? But can I go to the right if this is saying x is less than 0? If it's saying x is less than 0, that's going to go to the left of my starting point, right? Correct? So from here, I can't go down one, right one. So I need to go up one, left one. Okay, so I took my x value on the domain, plugged it in, that gave me a starting point. Then I used the slope to make the line. But I couldn't go to the right like you normally would because this says x is less than 0, which means it's going to go to the left. I'm going to do the same thing to start this next piece. So I'm going to take 0 and plug it in to get my starting point. 2 times 0 is 0 plus 1 is 1. Is this going to be an open or a closed circle? Closed. So start at the point 0, 1 with a closed circle. What's my slope going to be? 2, or 2 over 1. And if x is greater than or equal to 0, that means we're going to go to the right. So from my starting point, I'm going to go up 2 and right 1. To draw my graph. Okay, I want you to try that same thing for the next one. Even though there's a fraction there, don't panic, because when you plug in that starting point, your fractions will go away. You'll just need the slope, which is rise over run anyway. So don't panic about the fractions. Just follow that same process. Find your starting point and then use your slope to graph to the left and to the right.